My name is Ketsira Pierre. I'm a PhD student in the Plant Pathology Department at the University of Florida, and my research is supervised by Dr. Schwab Zhou at the Tropical Research and Education Center in Homestead, Florida. And my research is all about tomatoes. Did you know that South Florida, famous for its beautiful beaches and bustling nightlife, also has one of the most diverse agricultural industries in the country? The state's year-round tropical climate make it a perfect place to grow a wide variety of vegetables and tropical crops. Tomatoes, a staple in kitchens around the world, are among the most widely grown vegetable crops in Florida. Florida's fresh market tomatoes are ranked number 1 across the U.S. and are essential to the state's agricultural economy with a total value of over $300 million. Unfortunately, Florida's warm and moist climate has made it a hotspot for many plant pathogenic diseases. My research focuses on a phytobacteria called Xanthomonas uvascatoria pathovar perfringens, or Xanthomonas perfringens for short. This yellow pigmented bacteria causes bacterial spot on tomatoes. It is widely distributed and is present everywhere tomato production occurs. Xanthomonas perfringens is a foliar pathogen spread primarily by overhead irrigation, wind, and rain. The pathogen enters the tomato plant through the plant's natural openings and tears caused by damage to the leaf's tissue. Bacterial spot on tomato is notably characterized by circular necrotic lesions, often surrounded by a chlorotic halo. As the disease progresses and more lesions develop, lesions can merge, eventually leading to defoliation, yield loss, and reduced fruit quality. When the conditions are favorable to disease, up to 50% yield loss has been reported. Due to the pathogen's constant evolution, there are no commercially available resistant varieties. In addition to the biotic stress caused by diseases, growers must also manage abiotic stress. Florida's soils present challenges due to its low organic matter content and rocky texture. To produce healthy crops, growers need to regularly apply fertilizers and nutrients. Unfortunately, this can easily lead to over-fertilization, which combined with poor irrigation management practices and saltwater intrusion can result in the accumulation of salts in the soil. My research explores the impact of soil salinity on tomato plants, as well as the interaction between soil salinity and bacterial spot disease. To understand this relationship, we have conducted a series of greenhouse and field experiments where we use varying concentrations of salinity treatments prepared by adding sodium chloride to tap water. Desired salinity treatments were confirmed using an EC meter, which measures the amount of solutes in a solvent. We applied these salinity treatments to 5-week-old tomato plants every 2 days. Then we inoculate half the tomato plants by spraying a bacterial suspension of a locally isolated strain of Xanthomonas perfringens. To create the humid environment conducive to disease development, we place the tomato plants in a moist chamber for 48 hours. After 3 to 5 days, lesions will develop and we will start evaluating disease severity and progression over the next 3 weeks. Throughout the experiment, we take various samples and measurements such as water leaching, soil samples, height, and weight, and we also collected different photosynthesis parameters like CO2 assimilation, transpiration, and gas exchange using the CIRUS-3 portable gas exchange analyzer. After collecting all of our data, we perform statistical analysis and generate tables and figures to interpret our results on how the plants and diseases respond to our treatments. Through this work, we have found that compared to other crops like basil, snap beans, and squash, which were also evaluated, tomatoes were more tolerant to salinity. In addition, the salt treatments do have a negative impact on plant growth and physiological parameters. However, the salt treatments do offer a beneficial priming effect on the tomatoes, making it more difficult for the pathogen to enter the plant and cause disease. Less disease is consistently observed in our salinity treated plants compared to our control. Overall, our findings deepen our understanding of the relationship between tomatoes, salinity, and bacterial spot on tomato, ultimately allowing us to help growers create more sustainable agricultural practices and ensure that nutritious and healthy food is available to everyone.